Okay, now we want to understand where we could install control components or what are locations of control components. We could have three main locations for control components: on panel, in panel, and outside panel. On panel, um, so here, this is the panel. And here, here you could see on panel location, and here you could see in panel location. Usually we have a safety door here, and the door is locked, so operator usually doesn't have direct access to these elements. And in machine location, so elements could be installed in anywhere on the machine on any location. So we have a note here. Recently, for space-saving reasons, there is a remarkable tendency to install control components directly in machine. Okay, so for this specific example of food manufacturing or food processing line, we want to see what we have inside on panel location here. So we have a push button switches, which they pass a signals to the control device when the operator adds a mechanical force. So push buttons or switches are a type of inputs. Temperature controllers, counters, digital panel indicators. So these are digital panel indicators. They show temperature, pressure, level, flow rate, or product count to the operator by using an alphanumerical display. Indicators, so could be mostly they are light indicator, get the operator attention or show status of factory equipment by using light and or sound. Okay, so these this one could be, okay, this one is most likely a safety button, but these are pilot lights. So these pilot lights are type of indicators. And you have programmable terminal or HMI here. You could see the HMI here. So let's see what we have in panel location. Vision system, power supplies, which they supply electricity to the control devices in control panel and in machine. PLC, servo systems or drivers, they move, rotate, or process the target product more high speed and accurately. They have inverters, generate the alternating waveform and control the speed of motors. Relays turns the internal contact on and off using an electromagnet. Timers and counters. Let's see what could we have on in-machine location or outside panel. We could have a vision system, smart sensors, limit switches. What are limit switches? They pass a signal to the control devices when materials add mechanical force. Basic switches. Again, the basic switches, we need mechanical force to activate them. Proximity switches, photoelectric sensors, servo systems, inverters, thermocouples, and auto ID systems or barcode readers. Okay, we are done with different sections of this food manufacturing processing line, we want to see what could be a related division of a factory. In a factory, we have management floor, manufacturing floor, and inspection and shipping floor. So here you see the management floor. The next one is manufacturing floor, and the last one in inspection and shipping floor. And you could see the truck is waiting at the door of warehouse to be loaded by the product. So what are related divisions? What do we have on management section floor? Management section floor, we manage the production line. So you see it's connected via production instruction or Ethernet to the manufacturing line. So we send the instruction here, and what do we get back from the production floor? We get the production results back to the management floor. This floor is connected to another factory, to other partners, and to the headquarters. Manufacturing line floor, we already discussed what are the processes and stages we have here. And in sorting and shipping floor, you see boxes of different products coming, and we need to sort them out, stack them, and finally load trucks.
Now we will move on to another topic, typical control components. We have three main categories: input devices, control devices, and output devices. All of these components could be seen in different locations: in panel, on panel, and in machine location. Typical input devices include operational switches, detection switches, and sensors. Okay, operational switches or operational switch is operated by a person such as operator in the factory. It has at least one contact, either normally open contact or normally closed contact. Some switches have both contacts. So as you could see here, we have normally open contact. So we need to close the contact manually, and then the circuit will be closed and the lamp is on. Operation switches, the normally open contact is open until the switch is turned on. At that time, the contact closes and completes an electrical circuit. So you see, this is the normally open contact. It's normally open, the circuit is open. We need to close it, and we need to activate it, push the button, and then it will close the circuit. Operation switches, the normally closed contact is closed until the switch is turned on. So another type of operation switch is normally closed one. We need to activate it to open the circuit. So here, this is the default mode, and when we activate the push button, when we activate the switch, then the circuit is open. Detection switches are another categories of input devices. Detection switch is operated by materials in factory automation line, such as products on a conveyor. It is unique that detection switch has changeover contact, or SPDT, single pole double throw contact. Okay, so the difference between the detection switch and operation switch is that on operation switches, operator usually activate the switch, but here in detection switch, the switch usually gets activated by, let's say, material. Okay, so this is a material, a piece of another machine, or a piece moving on the conveyor, and the contact of the material and the lever of the detection switch will activate the switch. So these type of switches could be either normally open or normally closed, or we could decide which of them we want to use. For example, on this one, you see we use the normally open one, and when the switch gets activated, it closes the circuit and the lamp will be here, let's say, on. Okay, detection switches, again, you could see operation of a detection switch. This is a roller or a lever of the detection switch, and here we have a car lift, and at the end we have these detection switches for the safety to stop the car lift at the basically very end of the travel. Okay, other type of input switches are sensors. A sensor is a device that controls the flow of electrical current using a solid state device such as a transistor instead of a mechanical set of components. Using a transistor means the sensor has a very high speed response to input changes and a very long life with compared to mechanically operated set of switching contacts. Okay, so opposite of operation switches and detection switches, which gets activated by a mechanical force, here in sensors we have a transistor, and the sensor closes the circuit based on different type of inputs, let's say sound or light, or we will discuss other type of sensors like inductive sensors and photoelectric sensors, and it closes the circuit based on, let's say, electromagnetic field or photons coming to the sensor. Okay, so sensors, there are many sensors to control the flow of electric current, and they are classified by how they detect input changes. The most typical types of sensors found in factory automation are photoelectric and proximity sensors. Photoelectric sensors detect an object when the amount of detected light changes, and proximity sensors detect an object by the change using magnetic or electric fields. So here we have one type of a photoelectric sensor, which is a true beam photoelectric sensor, and you see when the object obscured the light beam, then the sensor either will close or will open a circuit based on its type. And proximity sensor, when an object gets close to the sensor and comes to a specific field based on the electromagnetic field, it could detect the object and closes the circuit. So here you could see that these, either of these sensors could be represented by a type of a transistor, which on this example, transistor closes the circuit when it detects an object. Okay, so we'll move on to the next main category of control components, which is control devices. The output devices are operated by the control devices according to the signal from the input devices. So relays, timers, counters, temperature controllers, and in general PLCs or programmable logic controllers are part of these categories. Okay, so what are relays? And relays are the most important control devices because the other control devices somehow work based on a relay functionality. In facilities and machines in the factory, the output devices are operated by the control devices according to the signal from the input devices. The control devices decide the rule or order of operations. A relay turns contact on and off using an electromagnet. Okay, I'm going to go through these bullet points and then explain the figure. Relays pass signals from the input devices and operate the output devices. So here we have input device, which is this switch, and we have output device, which is this lamp. So we want to pass the signal from the input to the output by the relay. But we want to indirectly control the output. Relays is composed of two sections, a coil unit and a contact unit. These sections are electrically insulated. So we have coil unit here and we have a contact unit. All this part you see in this dash line triangle could be considered as relay. Okay, so this is a relay, but relay is composed of two main sections, coil and contact, and they are electrically insulated, so there is no any electrical connection between these two. So we have two separate electrical circuits. Here we have a low voltage or the DC circuit, and the other one is AC circuit or usually a high voltage circuit. Relays can contain multiple contacts in a contact unit and operate these contacts at the same time. So we could activate multiple contacts by one coil. So here, this is our relay, and you see when a switch closes this circuit, we will have an electromagnetic field here that attracts the contact, and the contact lever will close the circuit and finally will turn on the output. Okay, these structures offers unique feature of the relay. Relays can handle two or more loads with one unit. Relays can switch a large load with small current. So this is a large load here operating on AC, and we are basically controlling that large load by small current, which is this DC current. Relays can transmit different types of electric signals. For example, AC loads can be switched using a DC input signal. Okay, this is basically feature 3 is very similar to feature 2. Okay, timers, other type of control devices. Relays and timers are very common control devices, and timers are very similar to relays. Timers also receive signals from the input devices and operate the output devices after a given time period. Timers are composed of 3 sections: time counting unit, a coil unit, and a contact unit. So here you could see we have a very similar circuit as a relay we discussed in the previous slide, but additional to that we have time counting unit. So what happens here when we close the switch, after a specific time the coil will be energized. Okay, so it won't be energized immediately, it will be energized after a specific time, a preset time. Timers also have unique features like relays. Timers can handle 2 or more loads with one input. Timers can switch a large load with a small current. Timers can transmit different types of electric signals, so similar features as relays. Counters count the number of signals coming from an input device or sensor. The counters then decides how and when to adjust its output based on several options selected by the user. So here we have a counter with the preset value of 10, and already 5 bottles pass on this conveyor, so the counter counts up from 0 to 5, and finally the last bottle will pass, the 10th bottle will pass, and the counter reaches to number 10, which is the preset value. At this time, when the value of the counter reaches to the preset value, the counter or the relay of the counter will activate the output and will close the let's say circuit. So this is a pilot light, and the pilot light now is on. So now the operator knows the preset value number of bottles are already passed. Temperature controllers measure the temperature of solid, liquid, or gas and compare the measured temperature with the given target and decide how to adjust its output to make the temperature rise or fall. So here we have an aquarium, and you see the sensor, the temperature sensor is measuring the temperature of the water, and the present value of temperature is 18 degrees of Celsius, but our set value is 20. So we want to keep temperature of water at 20. So since the preset value is close the set value, the relay of temperature will close the AC circuit, and the output heater will be on to basically to inject heat into the water. So now after a while the temperature of the water will be 20. So temperature of the water raised from 18 to 20, and then since it's same as the set value, the relay will be de-energized and the heater will be off. Programmable logic controllers, PLCs, also process signals from input devices but controls its output devices according to the user programming pre-stored in the PLC memory. In this way, the processor in the PLC can accommodate many different combinations of input devices and output actions without a lot of rewiring. So when the number of inputs and output increases, if you want to use conventional relays, we need to have complicated circuit and wiring. And in case we want to change the logic, we need to change rewiring or change the configuration of relays again. To avoid that, we use PLCs. So PLCs get signals from input devices, different or variety of input devices, and could operate a variety of output devices at the same time based on pre-stored program on their memory. And operator or programmer of PLCs could change the program on these PLCs and load the new program on the PLC.